Good, bye.
Great. Thanks so much, Sean. It's fascinating to see, behind the curtains on what a startup is doing to ensure that that scale is actually successful. Because, well, at Dataiku we know succeeding in that scale is maybe the difference between success and failure, life and death. We know that technology is not the only factor, and Sean did a great job talking about how the organizational challenges that they're facing actually do translate into a question of scale. But, of course, technology is one component and a very important component as well. And so next up, we have actually some very close friends of ours at Snowflake who are going to be talking about how the technology component can scale seamlessly. And we've been working more and more closely with Snowflake recently. I can say that you have that clear feeling that there is some common DNA between the organizations. A team that's looking to do something new, build it from the ground up, to really deliver business value to the customers. So we have Anthony Schneider from Snowflake, Solutions Architect, who's going to be coming up and talking about all of that. Here you go, Anthony.
Thank you very much. Okay, very excited to be able to present to you our first year sponsoring with Dataiku. So very excited about this new partnership that Snowflake's formed with Dataiku. My name's Anthony Schneider. Sorry, another Australian accent for you. I am a technical architect. I've been working at Snowflake for the last 6 months. Very exciting time. I actually come over from a customer. So, I've lived and breathed data warehousing, data warehouse platforms, MPP systems for a number of years. And I was quite intrigued at some of the solutions that Snowflake were bringing to the table to solve in this space. So, I'm going to jump straight into it and talk about what companies need from their data warehousing solutions. So, these haven't changed over the years. I think what has happened with the cloud coming on board is the need for speed and quick deployment of these problems, or quick solutions to these problems, is really paramount. So, very familiar with these, I'm sure. The idea of concurrency, that idea that you can have thousands of users hitting the database on a Monday morning and then going away in the afternoon and needing to cater for that concurrency during the day. Scale, the ability to scale dynamically, elastically, instantly, both from a compute and a data storage perspective. Very easy to do in the cloud, but not everyone's doing it. Resiliency, so that idea of high availability, or the idea that having your system available 24 hours a day. So high availability out of the box. And finally, security. People, probably 5 years ago, I think they were more nervous about moving to the cloud than they are today. But still, with any platform that you're deploying within the cloud, you want to be sure it's secure and caters for those needs. So I'm going to talk about Capital One, which is one of our large financial institution clients in the US. So they were hitting all these problems, as I'm sure many of you have in the past. They had a real problem on Monday mornings around concurrency. So sort of what I spoke about earlier, 500 users hitting the database on a Monday morning, grinds to a halt, and no one can get their reports coming out. So that was causing them a real limitation in being able to service their internal business. Scale, they were really trying to build up that data science arm of their business. And you're all in data science here. You know that it's about proving hypotheses. So that idea of suddenly I've got a terabyte of data, I want to chuck that in a database and start querying it immediately. Their existing platforms just weren't able to do that. Resiliency, they're a bank, so they needed high availability. So we're talking 24 hours a day, 7 days a week, 365 days a year. So they really wanted a platform that had that resiliency, that high availability, without them having to have a very complex architected solution to achieve it. And finally, security. We don't need to harp on about that, but they're a financial institution, one of the large ones in America. So they needed that security out of the box. They didn't want to have to plug and play all these different components together to achieve that level of security that they needed as a bank. Anyone who's played in the Hadoop space knows that that's not trivial. So if you are working with these open source technologies, security can be a really difficult thing to implement. So they decided along that path that couldn't be fixed with traditional architectures. So I'm sure many of you have played in this space, this traditional architecture space. Shared disk databases, like the old Oracle platforms. Shared nothing, MPP databases, really pioneered that space a few years ago. Our founders kind of looked at this as a cloud-first strategy, though. they didn't fit into either of those buckets. Snowflake doesn't fit into those traditional architectures. So they had to come up with a new name. It's called multi-cluster shared data. And that's all around this separation of storage and compute. And that architecture has really enabled us to deliver some of these cool features that I'm going to show you in the following slides. So let's go through each of those challenges and how Snowflake can kind of help you overcome some of those, or how they helped Capital One overcome them. Usage patterns varying throughout a day. So let's use the World Cup as an example. Let's say England's playing France in a couple of weeks' time. Obviously, the usage during that day is going to vary. So you're going to have everyone jumping in early on a Monday morning and trying to get their reports out because they want to head to the pub to watch the football. So you get this real peak on a Monday morning of people hitting the database and querying it. Then they all go to the pub at lunchtime. You have absolutely no one running any queries on the database. So it's really stagnant during that time. Obviously, we'll say this is a French company. They lose the World Cup. They all come back in and start hitting the database again on a Monday afternoon. That is impossible, really. You know, I spent years trying to size a database, to meet those peaks and troughs in demand. You can't size a database for the World Cup eventualities. So the idea of actually trying to resize a traditional database on the fly, or even in static when you can prepare for it, that can take months, weeks in the old traditional world. Snowflake, thankfully that problem's gone away. So you only pay for what you use. So that Monday morning or that World Cup final, when everyone's come in and they're slamming their reports, Snowflake will dynamically scale out and support that big influx of queries on the morning. As they all go to lunch, watch the football, no one's running any queries at that time, so the compute's going to scale all the way back down to the point of nothing. During that lunchtime period, those couple of hours, you can be paying actually $0 for Snowflake during that time in the middle of the day. As they jump back on, someone spins up Dataiku, runs a select star. Behind the scenes, Snowflake can automatically, dynamically spin back up and start running queries. So as an end user actually running that query, you had no idea that the database or the compute during that time was actually not being used and you weren't paying money for Snowflake. So that's how we solve that concurrency problem. It eliminates the need to have a massive system to cater for these peaks and troughs. So you really are scaling up and throwing as much compute at it during any point in time in the day to cater for that demand. Scale. So how do we achieve the scalability that Capital One wanted? I think this is a good slide that gives you an overview of the Snowflake architecture and how it works. So I talked there about the idea, analyst comes to you on Monday, says, I have 2 terabytes of data, quickly want to do some analysis on it. Because our database, at its core, we are a database, so at its core, we build our tables, schemas, views, everything you're used to, but behind the scenes, we're building that on blob storage or S3 storage in Amazon. So that idea is you don't need to pre-provision a cluster size or anything like that. It will just dynamically grow depending on how much data you throw into it. So load a petabyte of data in, maybe that's extreme, but load a terabyte of data in on a Monday and it will dynamically grow to cater for that demand. Then the second probably important concept is this concept of virtual warehouses. And this is another name for compute clusters. You can have as many of these compute clusters as you need to cater for the various areas of your business. So you can have hundreds of these. This is probably a standard implementation where people have a dedicated virtual warehouse or a dedicated compute cluster for their data science division, and then a dedicated compute cluster for their BI users. And that's really how we support that resource management. So there is no way that a data scientist doing some crazy hypothesis is ever going to impact those BI users. That compute is segregated, so both could be accessing the same data, but actually not competing for resources. So data scientists will tend to scale to have a very large compute cluster, and your BI users might not need that much compute. They can have a very small, cheaper cluster to cater for those BI reports that run on a Monday morning and through the week. And what we talked about earlier is that can also scale out. Again, all this happens automatically and dynamically behind the scenes. So as soon as that BI warehouse says, okay, I'm maxed out, too many users are running against me, it will dynamically grow to meet those new demands of users. As they go away again, it will dynamically shrink down automatically to save you costs. So it all happens behind the scenes automatically for you. Now the resiliency challenge, we love the cloud. Good partners with Amazon and now with Azure. But the idea of resiliency out of the box in the Snowflake platform comes because of that strength of the cloud and the cloud's architecture for multiple availability zones. So our tables and structures, yes, they are stored in S3, obfuscated from you as a user, but we use that as our underpinning data file management system. And that actually replicates the data across those zones. So you get 3 levels of replication of your data just out of the box. And that builds that confidence that you're not going to lose any data throughout the year. Also, the virtual warehouses, those compute clusters that I talked about, they can actually scale across those availability zones as well. So the idea could be that it has happened once before where a zone in Amazon's gone down. What Snowflake can do behind the scenes is actually realize that's happened, move your query into the next zone, and continue running. So as an end user, you had no idea that that actually has happened. So that's how we achieve that high availability, and that's why Capital One was so impressed that just out of the box, they were getting really that high uptime of availability. And the other layer I haven't talked about is this service layer. So we're an ACID compliant SQL data warehouse. So we have a metadata store within this service layer, handles every transaction that's being run, handles all the query optimizer. All that logic sits within this cloud services layer. And again, that's replicated across those 3 zones to have that high level of availability and resilience. And security. So very hot on security. We made a lot of efforts to work on our security story as a platform. Multi-factor authentication pushes to your mobile device. Lots of people using us with federated authentication, Active Directory. Access control that you all know and love as data professionals. So role-based access, table, schema. All that exists within the Snowflake platform. Every single row of data that you insert into the Snowflake platform is encrypted at rest. So we don't give you the option. You don't have to turn all the knobs to make that work. It just happens out of the box. So you have that confidence that every single row of data that you load in is encrypted. Finally, we have some of the strictest certifications in the US, PCI and HIPAA compliance. So we've got a lot of US health organizations, banking clients, and they're all quite happy that we meet those requirements. So what was the impact of bringing Snowflake in at Capital One? You can probably guess that concurrency problem went away. So believe it or not, Capital One had a DBA that used to come in, I think, on a Monday morning. And their solution to the concurrency problem with their existing platform was that he used to lock users out, kick them off on a Monday morning, and that was solving concurrency. So Snowflake didn't want that. We didn't think that was a good story. So Capital One now, that guy can sleep in on a Monday morning, and the database just scales as more users come in on a Monday morning. We talked a bit about scale. The data science team, where they used to have to sort of say we can't do that use case or we can't test that hypothesis, they've been able to do that now, their own dedicated compute cluster in Snowflake using the same data that the BI team uses. Another interesting thing that happened at Capital One was their internal bill back. So because they separated the compute for their data science team versus their BI team, you can internally see exactly how much money the data science team is spending running their queries. So in my last organization, we just had one big MPP platform. Data science was doing some crazy stuff, really cool stuff. And then they'd go to sell it to a consumer, but had no idea how much money that was costing because they were just using this massive 200 grand a year kit. In this way, they're able to exactly see how many compute credits were being spent on running those queries. And then they can build a costing model on top of that. Resiliency, they were happy what came out of the box. They could throw away their backups. Didn't need to do backups anymore. They got that all out of the Snowflake platform, out of the box. But also they went a level above and they did East Coast, West Coast replication, which is very cool. So in that weird circumstance that the whole West Coast of America gets wiped away, Capital One's still running because they've got a dual platform layout in the East Coast and the West Coast in America. And the built-in security. So internal stakeholders were very nervous about that, but they were happy with what we brought to the table from a security perspective. So I'll just recap then on what Snowflake is and what we can bring to the table if you are having these challenges at your organization. A complete SQL database. So we're not NoSQL, we're not a document store, we're not a bunch of open source components that have been packaged together. Our founders wrote an entire new SQL engine from scratch. So we are a complete SQL database, ANSI SQL compliant. So that movement from an existing on-prem SQL platform into Snowflake, very easy. I did it myself, didn't take long. And I'm not very good. Automated management, so no indexes, no statistics. I can't believe some databases, you still have to update statistics. All that work, reclaims, vacuuming, all that goes away. This is a new platform built on the cloud. You don't have to do any of those boring DBA type activities. All of your data, we haven't talked a lot about that, but the idea of JSON data, Parquet data, XML data, so those semi-structured types of data, you can actually drop them into the Snowflake platform and query them using a SQL interface. So we're actually seeing a lot of use cases where we are the data lake, where you're just dropping all that semi-structured data into Snowflake and starting to query it directly using a SQL language that we're all very familiar with. All of your users we've touched on, so just throw as many people at it. We love those challenges. Data sharing is a new feature, but the idea about being able to share, let's say, a terabyte of data or a very large volume of data immediately with a customer or a data consumer, it's a very cool feature that it enables you not to have those FTPs, S3 bucket sharing, and all those complexities. And I touched on that before, paying only for what you use. So you only pay for the compute credits that you use, and it's per second billing. So if a data scientist wants to run a query and run it within 2 minutes, he's only paying, or she is only paying 2 minutes of compute time. So there's actually no benefit to having a smaller cluster and running for 4 minutes. You may as well just get it over and done with. You're paying per second and then spin it back down. So the idea of getting things done quickly is very easily achieved. Now we are a software as a service platform within the cloud. So deployed in Ireland and Frankfurt in Europe, East Coast, West Coast in the US. Very excited about our movement into the Azure Microsoft cloud as well. So we're in live preview in the US. So if there are any people here that don't want to make that move across to AWS and want to work in Azure, we are starting to take customers into that cloud as well. So very exciting times. And we're in my home country, Australia, there as well. So there's one more thing I just want to touch on in the last couple of minutes is around that data sharing capability in a bit more detail. So just to emphasize how powerful this is, as a data provider, let's say I have terabytes of data and I need to share that with my clients or with my consumers. By creating a secure data share, I can immediately and instantly share as much data or as little data as I want with my consumers instantaneously. That's because data is not moving behind the scenes. I'm sharing it with their account, with all their security, their users, but I'm not actually moving data behind the scenes because it's all in the S3 blob storage system. So that idea of being able to create a secure, well-managed data share and allow external people to access your data is a very powerful story for creating a data economy. I think Localytics is the best example of this, our US customer that embeds their SDK into mobile phone applications. 25 trillion mobile events, so petabytes of data within his fact table. He was hitting limits. There's some good blogs out there if you ever want to read it. Michael from Localytics. Basically, it just exhausted the MPP platforms that I talked about earlier, needed a new solution. So brought in Snowflake, got all those benefits that we talked about earlier, but then this really transformed his business. So he had to share those trillion rows of events back with the app providers, back with the app developers. And he said he had a whole team of 20 people, doing FTPing, S3 buckets, permissions, extracting the data out. They had to load it back in. With data sharing, he was able to, one SQL statement, create data share half of those trillion events with my consumer in the bottom left there. Instantaneously, that consumer, that app developer, got access to about 1 trillion rows of data. He said that that was phenomenal. He's never seen the ability of doing that via those old mechanisms of passing data in files. It just doesn't work. So it's a very interesting use case, and there are some blogs and videos that if you are interested in how he's orchestrated that, but we're seeing it take off a bit in Europe as well. So just wrapping up, for those who want to get started, excitingly we are on the AWS Marketplace as well, so jump on there, spin up. We love people thrashing the platform and doing what they can do. Free credits come with that, or you can speak to our sales staff out at the booth today. And as I mentioned before, the new Dataiku Snowflake connector. So please jump online. It's a plugin that you can download in the latest version of DSS. but we encourage you to just jump on, have a play, and build out those data science use cases. So thank you for your time.
Great. Thanks so much, Anthony. Frankly, we've been looking out on the technology landscape for a while, always looking for what's new. I wasn't expecting it to come from the data warehouse space, but really that's what we're seeing at Snowflake, and it's really cool.